Welcome to a video on how to find angles given trig ratios, specifically using degrees. And we're going to go over several examples. We're going to have examples that involve finding quadrantal angles, also special triangle angles, and if it's neither special or quadrantal angles, okay? So starting off with first example, it says to find all angles between 0 and 360 degrees. Pay attention to this because if it said 0 up to 2 pi, then the answers should be in radians, okay? So always pay attention to what the question is asking because then it specifies what they're looking for to see, angles or degrees. So the best way to do this, I always like to think of sine by definition. This is a ratio of two sides, and I ask myself, which sides is it? Is it x, y, or r, and how are they related? So sine, if you remember, it's y over the r. Then I would ask myself, is that a possible thing for a special triangle? And something to keep in mind that these two right here, the root 2 and 2, the root 2 is always the radius for an isosceles triangle that has a 45-degree angle, and the 2 is always the radius of the 60, 30, 90 triangle. So because the radius here is the 2, I believe this would be the special triangle, and the root 3 is part of that one. The next thing I like to think of is because this y is negative root 3, I know I have to be below the origin to draw this, and this root 3, you should know that when you're drawing the 30-degree, 60-degree, 90-degree triangle, the 30-degree across from it is a 1, across from 60 is root 3, across from 90 is the 2. So it really helps to recognize what is the related acute angle if you recognize that across from root 3 we have a related angle. Related acute must be the 60-degree. All right, so as you're drawing it, you want to draw it more or less to scale so it makes sense to you. So as I said, it's going to be below the x-axis because y values are negative. So we have below the x-axis the 60-degree related acute angle on both of them. And we have the y value is negative root 3 here. This is negative root 3 here. This is 2. This is not necessary to record, but just to make sure that you understand. You can also follow the cast rule. So cast rule says that cosine is the only one that's positive down here, and tangent is the only one that's positive down here, meaning sine is negative in both of these. Cast rule I don't like using just because it starts in quadrant number 4. Some people talk about an acronym, all students take calculus, so that it starts in quadrant 1 and goes around. But I prefer to just use the definition instead of this, but it is really up to you what you choose to use. So now that you have the related acute angle and the positions in quadrant 3 and quadrant 4, all you have to do now is quote the angles. So this first rotation, remember we always want to quote from 0 to 360. So we don't want to rotate in a negative direction. We want to rotate in a counterclockwise direction. So this first one right here, I'm going to call this theta 1. So this theta 1 would be a straight edge, which is 180, plus this 60 more. So that's 240. And theta 2 is this one right here. So it's almost full revolution, 360, but 60, it's missing a 60 piece, so that's the 300 degrees. In general, if you were ever asked to find all the angles, not just the two within this revolution, so in general, the solutions are theta is equal to 240 degrees plus or minus, but I'm going to just record plus here, 360 degrees multiplied by an integer number, k. So this integer number, because it's allowed to be positive and negative, that's why I don't have to write down plus or minus. The reason why it's 360, because it takes 360 as a full revolution for this cycle to repeat. So if I wanted to get another angle that's just like 240, I'm going to have to add 360, and again I'll land on exactly the same arm of the terminal arm. Okay, so that's one set of the solutions, but you should also write down or It could also be the 300 plus the 360 degrees multiple, okay? So in general, this is what you would do if you were ever asked for a general solution of all of them. All right, next question. We have cosine is equal to 0. So definition for cosine is x over r. So this is not written as a ratio, so I'm going to record it as a ratio. We have a radius of 1, and x coordinate is 0. So there is no triangle here. This one is an actual quadrantal angle here, okay? So you have to think on the unit circle, where do we have x being 0? Well, x here is 1, here x is 0, here it's -1, here it's 0 again. So we actually have two positions where the picture could be. So rotation over here could be this θ1, which is 90 degrees, or it could go around like this to θ2, which is 270 degrees. Okay. We have a few more examples. Tangent. The tangent question here, I'm going to again record it as a ratio of numbers, so -1 over 1. It could also be 1 on top and -1 on the bottom. The reason for this is definition for tangent is y over x, and both y and x are allowed to be negative. In the previous question, I had this negative here, and I didn't have to consider that because radius is never negative, so it's only y that was negative. If you're using cast rule, this would not matter. So with cast rule, you should know that tangent is going to be negative in quadrant 2 and 4. As I said, I don't like using cast rule. I prefer to think of the definitions. So here we have a negative y value and a positive x or vice versa. So, and they're both equal in size. Both of them are 1 and 1. So it has to be the isosceles triangle. So it's important to recognize what's the related acute angle. So with cast rule, you're really just thinking about where to draw it. But then if you don't draw it accurately, it might be harder to figure out what is the related acute angle. So that's why I like to think about the actual numbers here. So drawing a 45-degree angle in both quadrant 2 and 4. Remember the related acute is always labeled towards the x-axis here. And so final answer, we just need to quote this right here would be θ1, and it's 45 degrees less than 180 rotation, so that's 135, and then this rotation here, θ2, is 315. I'm going to do a general solution for tangent because it's slightly different. Tangent has a period of 180. So technically you could just write down in general, you could do just theta is equal to 135. You could just use one of these. You don't have to use both, and just say plus 180 multiple, and k is some sort of integer. Once you learn how tangent function looks, then this actually will be really clear why it's 180 here. If you forgot, and you could just record 135 plus 360k and 315 plus 360k. It's also true, it's going to give you all the answers, but it's just some of these are going to be basically the same ones. So I would say this is the best way of recording that. And you'll have a chance to practice this more when we get into more of the trig solutions. All right, next question, cosecant. I'm going to record this as 2 over 1. Definition of cosecant is r over y. So once again, I ask myself, is this truly a special triangle? And we need a radius of 2, and here we have radius 2. 90-degree triangle, and we do have a size of 1 that corresponds with it. So really pay attention to that, because there could be a trick, something like it could be, I don't know, tangent is theta is equal to, and let's say it would say √3 over 2. So it looks like it's a familiar ratio, but then by definition, this is y over x for the tangent, and we never had an x of being f2. It's always the radius that's 2. So really pay attention to that. It's not only the numbers you have to pay attention to, but what they actually represent each time. Okay, so back to this question. We have radius is 2, and the y value is 1. So I'd like to think, okay, we have y across from 1 is what angle? The related acute must be the 30-degree angle. So, and it's positive y, so I'm going to be drawing in quadrant 1 and quadrant 2. Again, you can use cast rule if you so wish. So I'm going to draw 30-degree angle for both of these. And so finally answer theta 1 is the 30 degrees. Theta 2 is 150 degrees. General solution for this one with cosecant, it's same thing as sine and cosine. So general solution, you would say theta is equal to 30 degrees plus 360 multiple k, or 150 plus 360 multiple of k. All right, next question. I think these are going to be the non-special type. So you have to have your calculator handy and double check that it's in degree mode. Otherwise, things will be coming up in the wrong answer. So I'm going to still record this as 5.61 over 1, so that the definition of cotangent is x over y. Because it's x and y, I could have negatives on both of these. So that means I know it has to be in quadrant 1 and quadrant 3. Quadrant 1, both x and y is positive. In quadrant 3, both x and y are negative. Or you could use cast rule. By cast rule, you'll know that all is positive up here, and tangent is positive here, and cotangent is reciprocal of tangent, so it would be down here too. So because it's not special, I can't really tell what kind of angle this would be. Related acute, who knows what this would be. So instead of trying to figure that out, you just use a calculator and find the related acute by using tan inverse. So first of all, cotangent, rough work on the bottom, cotangent of omega, so this is the Greek letter omega, is 5.64. That means tangent is 1 over this 5.64. Remember, you're doing a reciprocal of the ratio, not the angle. And then to get the omega by itself, you would do tan inverse of both sides. If this ratio is a negative, you could think of what we're looking for is the related acute, so you can write down omega with subscript r. So we're looking for the related acute angle of this ratio. If there's a negative there, you could drop it because we're just looking for the related acute. So when you do this on the calculator, it gives you approximately 10 degrees. So now you know that when you're drawing in quadrant 1 and quadrant 3, it's a 10-degree angle to the x-axis in both of them. And to finish this off, you would just say theta 1 is 10 degrees, theta 2, rotation, is 190 degrees approximately. This is not exact. All right, and in general, it would be, oh, I should have said omega, not theta, because we don't have thetas here. So this is omega 1, omega 2, and then in general, this is 10 degrees plus 180 k. If you have an equation that the ratio is not isolated, like it was here, that's the first thing you need to do. Get the sine theta by itself. So move the 3 over, becomes positive, divide by negative 4. You can also write it as negative 3 over 4, so that the radius is going to be a positive value. You should recognize that these are numbers not of a special triangle, so I guess you don't have to draw the triangle, but we need to find the related acute. So I'm going to write down theta with a little r subscript as a related acute would be sine inverse. So this is rough work, really. It's not going to give us final answers. It's just part of it, our answer. So sine inverse of this 3/4. Just drop the negative when you're finding a related acute angle, because it's always going to be a positive related acute angle. And when you're doing positive ratios, you're basically thinking first quadrant. So when you do this on the calculator spits out roughly 49 degrees. So then you think either with a cast rule, so cast, or all students take calculus, whatever you wish, or the fact that y is negative on the bottom two quadrants. So you're going to draw two terminal arms over here with a 45-degree angle in between the terminal arm and the x-axis, always towards the x-axis. Don't make the mistake of making it towards the y. So this angle here, theta 1, would be 229 approximately, and this angle here, theta 2, is 311. In general, it would be 229 degrees plus multiple of 360, or 311 plus multiple of 360 degrees. Just be careful when you're doing this rough work of related acute angle, the 49-degree angle. Don't start drawing this 49-degree angle in quadrant number 1. Always refer back to the original question where the sine theta is a negative ratio, and look at that. And another quick note about this general solution, if you're not sure whether to do 360 or 180, you look at your picture. If you have the angles as a straight edge between each other, that would be 180 between them. So if I were to take 10 and add 180, I would get that 190 anyway. So that's why you don't have to do the second version, and it's 180 here. All right. So last question, isolate tangent beta. So that's a Greek letter beta. So tangent beta would be 2 over -5. And then again, this is not a special triangle, so we're going to use a calculator for rough work for the related acute angle, tan inverse. Drop the negative of the ratio. We're looking just for the rough work here. What is the related angle? And you get 22 degrees roughly. And then you think back to the original, not this 22, back to the original ratio. Ratio here, tangent is negative. So either using cast rule or thinking about the definition of tangent, which is y over x, or slope, rise over run. So where is slope of a terminal arm negative? Well, slope is negative in quadrant number 2 and 4. So this angle here is 22 degrees, and this one's 22 degrees. And to finish off, you would state beta 1 is 158, beta 2 is 338, and so in general, this one, because it's a straight edge, you can just say one of them, so beta is equal to either one of them, doesn't matter, 158 I'll start with, plus 180 degrees multiple k. So the reason why this works basically is if you learned about sequences, if you were to create the sequence of numbers here, 158 is a solution, 338 is a solution, the next one would be 180 higher, so 158 plus 180 plus 180 again, 518, etc. So this is an arithmetic sequence, and it goes up by 180 each time. So if you work with that, you can use the sequences method. Just keep in mind that this is a sequence that's infinite in both directions. That's why this k here is element of integers instead of natural numbers. And that's why it doesn't matter which one you start with. You could start with that one or that one, because it really won't matter. As k goes through all the integers, you'll get all the solutions. I hope that was clear enough, and thank you for watching.